quite fascinating because it's kind of create a wave kind of thing in you can say in computer vision. Basically, you can say this is a I will not say a benchmark paper for to get started with it. It's something like that. You can, why it's there? You can say it's more like Cliff has a full form called contextual language image pre-training, basically by OpenAI. You can say basically of it we will go deep dive into that also on a very succession manner. But yeah, let's get into this. So if you will see, the whole paper is more or less around on this during that part basically, if you will say. So think more or like let me give you a more better understanding. Just give me a moment. Cool. So let me draw for the better one, I guess. Cool. So if you will see here, maybe we go to the down part of it. So just let's talk more or less around this part basically, which is more like let me. Cool. So if you will see here, or you can say the major focus is on the state of art computer vision systems basically. So what happened is we are training a large amount of image data set, or you can say image net, you can say image data set net basically, to like they are directly learning from the raw text about the images around that, which if you will see here, this is the main thing that they are working on it, like the 400 million part of it, right? But the main thing came aroused is like after pre-training also there's still a lot of inaccuracy we found during while we are learning a model, right? If you will see here, what in this they are doing this you can say part they are doing, this is called zero shot transfer, and I will also explain you what it is, why it is came into so much that loop. But due to this thing, if you will say due to this thing, it is totally impacting these 30 different activity, you can say OCR, action recognition in video, geolocation, and many types of the fine grained you can say object classification, you can say. Even also, for instance, also it also increases the accuracy of the, you can say, the encoders like ResNet 50, ImageNet, like these kind of stuff. Like it also help a lot of in many ways, right? So without needing any like this thing. So now what are the main thing that if we will consider, like what is the major motivating work that they came into play and why they are doing it in some kind of thing. So if you will see, or if we will compare this stuff with many more peeps around it, so it's more like before 20 years ago, if you talk about, there is also already an improvising in content based image retrieval. That means uh, thinking more like we are getting images on the basis of the text, like you can say Delhi, right? You listen about Delhi, around it you can know pretty much stuff around it, how it totally works. But in this paper we will try to explain more further, like how we can do it in a reverse order thing. That means from image can we get something out of text kind of thing. Why? Because obviously there is a at a certain point only we can only capture the data from something, like if we providing something text, it is generating, like it's more came into the, you can say, GAN part basically, you can say Gen AI part, you can say, and more or less like that thing. Cool. But if we consider more around it, how we can get into it, so let's get into it. So if you will see this part, this is talking about in this part basically. So if we will consider this here, trained on different machines, and they like, this is the main important part. If you will consider this part, this is the important part, which basically what they are working on, they're taking a lot of ImageNet data, and what they are actually doing, let me show you here, like in the next part, I guess. Let me give you that. Cool. So again, this is the main part, that like what, like this is called actually clip. This part actually called clip, and let me enter the drawing part, I guess. This is the part that is part called CLIP, of a contrastive language image pre-training. So let's see what is happening here. But before getting into this, what is zero shot method basically? If you will see here this part, what is actually zero shot prediction? So generally, when we train a model, we train a model on a supervised, that is the image. We have some kind of a label data set. But can it be possible without existing of a data set? Like there's some data set like data set of cat and dog, right? But can we do something like that without the scope of the data set? Can we predict the name of any pet apart from not only which is not a part of that particular data set? That is means if suppose I send you can say lion or tiger or maybe any animal, it directly and from those backward in our knowledge, can we make it like that? It's generally not possible. Like generally what it happens in zero shot, if we will consider around it, like let me consider it more brief maybe down part. So if you will consider in this manner, let me cool. So let me what we can do here. So there is some data, suppose, which includes dogs and cats. Cool. So generally in supervised learning, these are the label data set, right? This is the label data set. Like now how we can basically train a model before doing like train a model with without the like the basically if we passing a tiger here, if suppose if I'm passing a tiger image here, how we can improve it, right? So this is the part that I'm majorly for focusing on it. So let's deep dive into it, how we can do it. So what we can do here, we can basically make it more like functional. Like how we can make it functional, the meaning of it, and when I'm saying it making a functional, the meaning of it is basically train the dog and cat. Like generally as a human, what we did, like if we know something, if we basically suppose I never went to Japan, or maybe never went to maybe Thailand, suppose, right? But I know a cultural images shift kind of thing, right? So when I go there, I already knew some instance out of it. So what through my past experiences or the some old data set with the uh, maybe you can say with the by seeing the old images, I can consideration that this may be Thailand if I will go there. Same thing happening here. What we are trying to do, if you will see here in this part, what we are trying to do in the whole clip. Well, let me go to the let me cool. Let me make it more zoom. I guess. Let me zoom little bit just for you all so that it is understand better understanding for you. Cool. Yep. Cool. So what the basically they are doing, this is the image, and for every image this is something kind of you can say text part of it basically. And basically they here is also seen like we can improve the accuracy of data. So by the way, this all thing that we are doing, like I will tell you, this is pre-training. We are not training anymore anything right for now. So what we are doing, like this is a dog of image, and what here it is like paper, the Aussie pup, like this is the main authentication part of it, like the basically to understand part of it. What we are doing, we are passing with an image or text encoder. So those who didn't go to the first part of it, that's why. But the overall thing that we are doing here, we are passing into a transformer. Like those who this is a transformer. Generally in imaging we prefer resonate basically. Cool. But those who never been to our first research paper reading, they can go to our YouTube channel, you can find us. But the major thing is we are using generally transformer. It basically encoding, basically creating in a different embeddings. If you will see here, it coming into different embeddings, I1, I2, I3 to IN, same with T1, T2, T3 to TN. Now if you will see here, we are doing a dot product here basically, right? So we pretty much know this is the closest answer that we get. This is kind of true. Like if we ask like have there any relation with that particular caption. So what in the whole research paper there's a something point out they came into play in on Instagram. If we have an image, we have some caption to it, right? Like if you will see here, this is the caption to it, this is the caption. Let me go here, this is the caption. Cool. Okay. But if we consider more or less, like we have also hashtags also, like in Instagram. That's why if you will see maximum time the language model from Facebook, or you can say previously Facebook called Meta, basically they have a better language agnostic models. Even though when you put it out your story maybe on Hindi, English, no, sorry, Hindi, Bengali, maybe any regional languages, if you go to the translation part, it is actually directly converting to the English with the same sense. Why? Because the three properties that Instagram is doing better, first is obviously image, second part is caption, right? They're working on it, and third cool helps them to understand the whole scenario of it. So what generally we are doing if we want to create a label text in order to, so what they're doing, they're creating a normal you can say this is the basically prompt. We are doing a prompt engineering. This is done by humans basically. This is prompt. Cool. This is the prompt engineering that we have to do. This like here for simplicity, he writes a photo of of object, and it basically this is the words they basically carry out in an array. Basically, you can say cool. So he goes to a text encoder by a transformer. Same thing with the image encoder. You can say if you're not going with ResNet, you can go for the VIT, that is visual transformer. Even I gave this talk recently. I guess you can check it around. And again, it's multiplying. So basically, it get a better understanding how it totally working. So, so summary of our of this approach, if you will say, while maintaining a image model with jointly trained and a image feature extractor, we just add a linear classifier to predict some labels basically. This is what actually clip does generally, right? This is what actually clip does. And if we go here and we like see around it, the main thing that they're working like, let's read it out more or less. For example, reach on like if we will consider about the performance on the common benchmark, it is very lower. Clip is actually very lower in the normal benchmark. Cool. But if we consider on the zero shot setting, that is mean like we are giving them a image, a caption to that particular image, or you can say description of the image, which makes sense. Obviously it tells about this image has this caption, and which basically it giving a description of that particular image, which help us to understand what maybe other images can be. It at the end of the day it comes onto the convolution or the kernel part of it, how we are using it, right? So if you consider here 11.5 accuracy on image and zero shading, this is below the 88. Obviously it is very low. It is even below the 50% accuracy of classic common version. But why then, if everything is on based on accuracy and even the accuracy is very low, why we are considering? So let's see here. Predicting ImageNet related hashtags on Instagram images in effective pre-training tasks. Basically, it also helps because there is a hashtag also included. This is a third. Like generally in the computer vision, if we consider there's only image, some what they call caption, but the third, because the as many as factor or parameters you are having on which your particular model is run, it's improving. Like at the end of the day, like here is hashtags, like this hashtags, right? So this is what they are done on different data set. If you will say consider they have worked on this also a model called convert, which is known for, you can say, more to be considered more or less in the part of like convolution. Uh, it's also convert. Basically, it's more for the, you can say, the medical part. Basically, this is also a model, but it's kind of doing the same thing. So they are basically working on, and they find out Clip is very similar to GPT family. Basically, if you will consider this, Clip is very similar to GPT family, and why it's happening. Like the thing is because the when we consider OCR, geolocation, and active recognition part, it always better doing comparatively to that. So how it happened? So they go for the study of many years around it. They work on a 30 existing data set. So it is very competitive prior task basis. So let's go to find around more or less like what's happening. So like they're working on a linear probe part. So if you will see here on a transformer language based model, let me add the redrawing. Cool. If you will consider this part, like transformer language model kind of part, it basically have a lower efficiency if you will see from image process to zero shot image net accuracy, as I already shared about the zero net kind of part. So it is very comparatively to the normal part. This is the normal. If you will just doing a normal computer vision thing like that we generally did, right? And there's a transformer language which is very reduced in terms of backward. And when we are using clip model basically, right, there's a difference. If you go to three, there's a seven times, there's 7x improvement in the whole scenario, right? So clip is more efficient at zero shot transfer than the image caption baseline basically, if you will see. So after that they go have a more approach to, let's go to the more supervision part, like create more data sets. So this in the paper is more or less is basically focus on the dataset part of it. You can see here the whole dataset part of it basically. So we are not going into that. And again, same thing, they are working on the, if you will say, they're going on the another model. Let me open the draw part. Cool. So they are doing the same thing. They're going to the vertex part of it. They are working on it on the CNN and text transformer, as you see. Basically, they are increasing the, you can say, data basically. Cool. Till then, is there any doubt with someone? Let me check on the Discord part. There's no question, right? Cool. Cool, cool, cool. So I am hoping everyone is understanding what I'm saying. But yeah, cool. Let's go get back to the whole thing. Yeah, give me a moment, folks. Cool. So yeah, if you will consider generally clip model in a more better way, like here we are basically, again, if I will say on the last part to it, we are not training anything. Like here we are just doing pre-training. Pre-training doesn't include any training, but we are just doing a small process. It's not training, guys, right? We are not training at all here, if you will consider thing, right? Let me go to the next part. So here again, the same thing is basically the vertex part. As you see here, the image multi-class part of it, they are doing for the sake of it, other kind of thing. And same like with the whole thing, like they are creating more and more around, like if you will see the temperature parameter kind of, they are basically creating a mathematical part of it, how we are using the clip dataset kind of thing. For, and if you will see here also, the main thing that came arise here, they 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 basically focus on the ResNet part. If you will say, this is the ResNet part. Again, you can use VIT again if you want to use it, and again replace. And if those who pretty much know, this is the transformer attention paper that we, I guess, read last year. You can again check out you to get a more understanding behind it. And transformer style multi-head like that we did, again same thing happening. Transform, we are basically here what they are doing, they are basically incorporating or elaborating about the transformer model. Basically they are doing nothing with the model, they are doing nothing in this part. Basically they're just doing again and again part of it, same thing. If you will see, if you want to understand the basic, I will give you a basic understanding. They create, this is a basically Python based thing, you can say. Image encoder, they're passing an image. Text encoder, they're passing a text. Let me add a, so just here it passing image, here it passing a text, nothing more less. Then it normalizing it for the multimodal embedding that we did in attention paper, basically like that what we do in transformer basically. Then it is pairwise consigning the similarities, right? And basically, if you will consider, this part is totally transformer part. It came into the encoder and decoder. Cool. Now, now let's came into the most fascinating part to it. Like I'm not getting into the training part of it for now, but if you will see, this is zero shot learning. You can basically go in and understand to what it's doing. But the main part is this, that what I want to share with you. Just give me a moment. Yeah. So if you will consider the this part basically visual engrams. So in the next table, if you will see where with the clip model improves accuracy in ImageNet from the proof of concept. Now why how it is happening? Like if we consider in the previous part there is like 11.5%, but how it jumped to 76.2%? Like it's totally unbelievable, right? And even top five accuracy of clip model noticeably higher than a top one. How it like how it's happening? That's the main thing, right? Now the main thing why it's happening. So let's see in this part. If you will see, if we are not introducing the prompt engineering, this they are here they are saying doing a some kind of prompt engineering resemblance, there is an improvement in model. Even though if you will see here, just check it out here. Normal visual n-gram model, you can say it's doing 72, 11.5, 23.0, but by using clip, it increase a lot, right? If you will check it around here where I explained something, you all, yeah, this is the part basically. Cool. This is major part that we are doing is more focus. This part is really, but let me change the color for you to make it more understand. We'll make it, we'll choose cool. So this is the important part of it, that is prompt engineering. Here, this is the thing that generally people like, it's a default thing that when we're giving a prompt, it's a photo of some object, right? But you can also change this part to many things, like suppose if I write here, maybe we can write here, suppose like this is a cat, which is a category of and something like object, you can incorporate the list of the or the dictionary part of it basically. Cool. So again, not going into the thing why I'm sharing you this, because why prompt engineering is really important in these kind of model, because on the basis of prompt engineering only we can improve our model in a better way. That's the thing basically. If you will see, cool. Let me go to the again the last part to it. Cool. So if you will see here, there's a up now the most important part, like clip is significantly step towards practical zero shot computation. So why it's happening? So generally is meant for contextualizing the performance. When we say contextualizing, it means we are narrowing the whole data set to a one common output. So what it means like there's a lot of data points present, but we right now focusing on those we are just focusing on those which we got the more resemblance of features, you can say. Cool. That's why the diagonal part came in when we basically crossed when we do a cross with between image and the text part of it, right? And in maximum time, generally we did is like this. Let me go to the common, like generally with the clip model is morely, everyone thinks like how clip achieves a 95% reduction in number of errors, and on sun like same thing. So clip basically what clip does it, with the power of prompt engineering that they're adding to it, and again the imaging coders and the time coders give a simultaneous way of giving me more accuracy when we see in terms of resembling part of it. So let's get into, let me into the more so if we consider around the prompt engineering part of it, sorry for that. Cool. So this is the part basically total focus on the prompt engineering part, how we can improve the prompt engineering part. It only helps around it. So again, not into depth of. If you go to the next part of the process, it's more like how how this clip model is helping at the end of the day. The main thing that is arise in the zero shot learning. Okay. And again, this is the main thing if we perform around it. So suppose this is the also like cool. So this is the thing that we focus on. So clip model actually goes on the different data set, right? And this is what we found. Like this we like there's a lot of data set that is above this one, like above this one is doing great in terms of we never think of maybe we are going in much more better in the medical but if you consider here there's a data set very familiar ms data set, right? It's a handwritten data set. So through this we got like the digital handwritten data set doesn't require like this model is not able to do that. That how we are doing it, like if we consider around it. So there's a obviously the score the zero shot clip versus linear probe. So what is linear probe? You are obviously thinking of it. So more like if this is something called an image. Cool, this is an image, and we pass through on a neural network like one, like suppose this is a layers that we are add on. Cool. So what linear probe means? It means taking this part, this classifier, like so one, two, three, four, and last part. If I change the color to it, maybe let me part maybe. Just give me a moment. Let me go to the green part and choose this thing. Let me and add a one basically linear classifier. It basically gives a lot of classification part to it, right? So this part, it's kind of also basically clip is also, or you can zero shot learning kind of transfer learning you can say, because at the end what we are doing, we are basically this part, we are freezing this part, adding to the new neural network and adding one more layer which is kind of a linear classifier basically. Cool. So that's why there's a difference between what the zero shot clip versus the linear probe on ResNet 50, which is kind of also image encoder basically, right? This is what we are doing. So to more get into understanding of it, how it totally works or not. So at the end of the day, different data set came into play, and we are working around that part basically. So now let's consider more here. Let me go into the part of where basically clip model happening. So if the overall paper at the majorly focus on how it totally works. So if you will see here, like let me add a if you will see here, this is the normal ResNet 50, which giving accuracy of okay. This is these are the one of the biggest models. Cool. But these models are trained models. Here, just see this. This is not trained. It's not trained. It's just pre-training I did, which or not I, obviously the researchers did, and it basically matching up with the bitmap. You can understand this without doing. And with the Linear Pro, obviously they are doing on a clip part, but when we introducing clip with Linear Pro, there's so much drastic changes happened, right? There's a lot of this is the label, like you can the 16 label data we have, basically we have 16 classes you can say for every training examples, and just see the score, you can say the accuracy part of it. This is the 65% average score. You can consider this a metric for the accuracy you can say, and just see this is not trained. This is not trained. These are so much high, one of the biggest you can say models, but still it is doing better. And if suppose after this, if I train any model, there is so much possibility that it can touch 95%. Like there's a kind of a possibility that we can look upon it, right? Same thing. The whole thing is overall give the same kind of contextual part of it. If you will see, in addition to average performance of zero shot, clip and few model, basically the logistic regression. This is a basic model, right? One of the basic logistic regression, linear regression is the basic model. You can say add as a classifier at the end. That what we does for the linear probe basically, right? So this is the main thing that they are following more or less. And if you will see on the more around the data set part of it, right? What are the basically example that we can think of? They are focusing on what are the you can say, let me go to the drawing part. Cool. So you can see here there is mean is 20.8 and 5. So when we consider 20.8, it means the average part or median like 5.4. So you can say median can be 1, 2, 3, 4, 5. For every 5 part, there is increase on the basically dataset part of it, and mean is 20.8. There's average part is the value. If you consider the overall value, that is 20.8, where you can see 20, it's more like it's came under the image net. If you will see the value of 20.8, right? Even though in the linear probe, if you will say clip performance, this is the nor this line, if you will see, this is the ideal one. This is the ideal one. And if we compare these, all like MNIST dataset came into play, like these are the morely generalized dataset. But if you'll see those are nearly in the, if you see ImageNet, it is very near to the, you can say, the ideal one, right? Which is not possible before that. This is totally like overlap between the whole thing. Even the amnest is very far away from it. The reason is being that we deduce that this model have some disadvantage also. Like this is not for the digital handwritten model basically, right? We can't do something around it. We have to work around the more on it with the capability that you can talk around, you can go through around y is equal to x is a dash line. Basically, it basically explain about the on the optimal zero, like it is the ideal one. We can't go over that, right? This is the basically model. Same thing if you will see here, this is again a model, again ResNet 64. But if you will see here, there's a lot of the other lines. If you will see, this is the straight line which covered the about the ResNet, different ResNet 64, 16, 4, 101, like around that. The other lines, if you will see, these are very not drastic, and there's a lot of changes in the basically training part when we do on the training part basically. So which basically at the end of the day is the main thing is to minimize the selection effect that could raise a concern of confirmation or maybe reporting any bias. If we go to the weights of the any neural network that we are setting up, right? There are a lot of biasing came into play, which obviously not good for us. Like generally, this part, if we will consider, this part is bias. This is the add part of it. When we say y is equal to mx plus c, here C is the basically biasing part that we are going at, and M is the slope, that is the, you can say, weight part of it. You can say, not sorry, weight, misunderstood. Y and X is the weight part, and we are basically showing the errors, which the error is reduced from here to this part. This is a lot of drop of errors, you can say, right? It's called constructive loss basically. And you can say go to the different, and this is also a part of the representative learning, how from representation of the data from each bit by bit, how we can reduce or how we can improve it, right? So again, this is the kind of for different model, what is the average score part of it, right? So if you will see here, they are working on a 12 data set. Here you are going for the 27 data set. Like they are just increasing the data set on the basis of that, if you will see, nothing less. But and they are giving what is the overall thing. If we go to the cliff vit, like let's go to the, these are the cliff visual unit transform. So if you will generally see the maximum times, the best score are the cliff vit, that visual transform basically, right? If we compare with the blue dot part of it, like these are the blue, right, in the left part, right, which is basically efficient noise student. It's basically another model, right? So these are giving the kind of some of the benchmark that we can work on, like why these models are working on it. And if we'll see Instagram pre-trained, like this line, pink line basically, this pink line is basically Instagram pre-trained, and again they are working more or less like, but the comparison with the ResNet thing, like just see this. This is the ResNet. This is the ResNet, and Instagram pre-trained have a better learning comparatively to ResNet. This is amazing, man. Like literally, right? This is how totally their data points work on. And same thing happened with here. Like if you will see ImageNet, if you compare logistic regression on clip versus efficient net, there's a maximum. I will not say maximum, but you can say 80% of models are doing better even the MNIST dataset is also doing better in terms of that, because logistic regression came in the place of the more on a textual part, right? That's the scene. And again, they are working on the robustness. Scalability is kind of sometimes issue around it. This is the same that we can say the lag part of it. Again, same thing from the image part. If you will see, this is the this is the ideal. If you will see, the dotted line is the kind of ideal or optimal solution. We are getting better on that. If you will see in the right part also, ImageNet score basically, or transfer score is generally the how we are going for a transfer learning part basically. That is called a linear probing basically. Actually, cool. And cool. So the again, let's bit talk about this, the kind of something you can say the important part of it. So for now, think like there is nothing a column called zero shot clip. Basically, just think like there's an image net. Cool. Let me see if I can make it more bigger. Cool. So if you will see here, let me add a drawing pencil then. Cool. So this is the ImageNet. This is the version 1 ImageNet. If you will see this banana kind of thing, ImageNet V2. Okay. Again, there's a lot of GenAI stuff also involved. Same with ObjectNet, ImageNet Sketch kind of thing, and ImageNet A, right? So before going into this, first of all, let's understand the graph first. Okay. So y is equal to x, this is a basically ideal robust model. And if you will say this is zero shot, which is very near to the, this is, you are seeing the difference, right? This is the, and this is the difference. There's a lot of efficiency. If you will see, there is a lot of efficiency shift around it, even though the, you can say the gray dots is more on the existing robustness techniques or standard ImageNet techniques. Like in comparison to that, we are doing better. But let's go into this part basically. So in initial, in the normal ImageNet, like they have a, we have a same, right? When we go to the ImageNet V2, clip zero shot performed well, 70.1, same thing, 88.9. This is basically came into like any like GAN part of it basically. This ImageNet R you can find out, right? 972.3, 60.2 comparison. Just see the growth rate. This is the total up growth rate, like 74.4%. That is totally unusual, right? If you will see, there's some part of GAN basically or GenAI part came into play because they're creating new images kind of thing, right? But still, in comparison to that, the accuracy is phenomenal around it, right? So how we can do this? So let me reduce the image for now. Cool. Again, the overall thing came into play is the this part basically. There's a problem when trying to fix 100 ways of classifier of the ImageNet to make prediction. So that's why when we say clip, we can instead of generate a custom zero shot classifier. Basically, what it actually means, it creating custom classifier of zero shot generally. Clip generally does it like, because what we are at the end of doing, prompt, we are at the human level, we are adding a prompt to it, right? Which actually generate a custom model to it basically at the end of the day, right? So which is kind of again, there's a lot of issues with scaling of this model also. I will share you how we can basically go around it. And yeah, this is the main thing you can find out. And they are basically comparison to the human performance. They are also did that with basically, is it better than human or not? They just give them like, if you will see uh, cool. If you will see, like this is the ideal one again. This is the ideal one. But if you will see, there's an adapt change shift came into place. If we compare to image, and this is a basic kind of a journal comparison to the logistic regression. This is the logistic regression one. Cool. So you can see the power of clip, how OpenAI is using those kind of thing. And you can say in YouTube data set basically, it obviously improve on a major scale, you can see, if you will see here. And they basically, in this one, they were work on about the human, like in comparison to human, how it better than, and data overlap part of it. So I'm not going into there, but this is the major thing. But if you want to understand more more about like clip, you can go to the openai.com research/clip. You can go there. If you want, I can share the link with you all. Just give me a moment. Let me go to Discord first. Add here in the section. Cool. And yeah, you can go there. You can find the basically how you can like just for the understanding part of it, basically. And if you go down here, basically it basically we are introducing a neural network called CLIP, which efficiently learn a visual concept from natural language supervision. This is the major and similar to the zero shot capability of GPT-2 and GPT-3, basically. Here the code also, like if you want, and this is the kind of the whole thing how it in terms of ImageNet and Cliff virtual visual transformer, how it works. They are giving a kind of percentage. I This is the same thing, like it's a kind of paper in a more block form, basically, you can say, right? Same thing happening with your photo of dog came into play, like this kind of thing. Same, they are giving just like how it totally works around it, like you can say around it, right? So this is the kind of takeaway you can basically come. This is the same thing, but it's more a block format. You can say this is the whole same thing in a block format. As the limitation, like you can say, it's struggling on the more abstract and semantic task, right? On the two data set, zero shot clip is slightly than the random guessing because at the end of that, this came into play. And again, like as it like on handwritten digits can't be like evaluated because the accuracy is dip. Like if you only achieve around it, right? So errors is more on a prompt engine. It depends on a whole the thing. When we say prompt engine is important, that's why like we generally classify. When we're talking about machine learning models, if you are prompting good prompts, that is the main thing around it. And if you want to go with the GitHub, this is the basically GitHub of it. And if you go there, this is the whole again the whole everything is go here. If you want to run in your system, you can also try that out, right? And this is the basically the GitHub part of it if you want to try it out around it. Cool. And yeah, more like there are a lot of examples also involved with this if you want. And let me go to the this is the Hugging Face doc also, even though if you want to try it out on the Hugging Face you can do that, right? And more or less I guess there's also one thing that I want to share with you, like, part of Hugging Face, you can say. This part they basically created a 14 patch VIT, basically part of it, basically. So let me give me just give me a moment, folks. And okay, Adarsh. Yeah, I guess I shared that thing already, but I don't think so. I guess it's added on description only. But if you want, like, yeah, sure, I can from next time I can do that. But like, I guess I give a title to the paper actually. So I guess this is it. I guess if you have any doubts in any moment, again, to process it on a very simultaneous manner, it takes a lot of time. I know that there's some point maybe there it's go out of your like before your head. I can say that, but be chill around it. It's just like exploring more and more around it. You can find out it very easily. So yeah, is there any question you can ask? Let me turn on my cam so that it's built bit like also I don't know it's laggy or not, I don't know, but yeah. So yeah, is there any question you are having? You can ask obviously. Cool. If you have any doubts, you can ping. You can be. I if you will. I am not actually a. I guess there is a paper dump channel also. If you want, we can discuss over that. Like I can dump some papers again related to these papers. Also, we can talk around. Maybe I'm thinking for the next month also. There's also one paper which is based on clip model basically. So yeah, I hope so. Kind of we can touch around it. But cool. hopefully everyone got some answers around it. But cool then. Again, I will share the links with you all. Maybe in the proper discussion channel, so no worries at all around it. Or maybe if anyone wants to share the links that I shared, that's also fine. That's not a problem from their side also. Well, then I guess we are on much time, I guess. Yeah. Maybe it's like 40 minutes from, so I take 10 minutes more, but it's okay, I guess. Cool. Cool then. So then see you folks. Maybe on the next, if you have any question, you can drop down in the discussion channel, or there's a lot of channels. You want, you can do it and share the things with you. And sooner we will drop the video in 2 to 3 days, I guess. And we will get back to ASAP as soon as possible. So see ya, folks. Bye bye. Take care. And I hope so. Everything is going fine. Yeah. Bye, everyone. See ya. Take care. And if you have any doubts, you can drop down in the discussion channel. I am there, obviously, for that. So, yeah, bye. Bye, folks. Yeah.